Everyone, welcome back to Short Notes. So in this video I have for you the question paper of Operation Research, that is subject of MCOM second year private CCSU University. So let's start. So I'll be sharing with you the answers as well. So the right answers are marked with the red pen, and these right answers are as per the answer key provided by the university. So let's start now. So in case the cost elements of one or two cells are not given in the problem, it means to assume that the route connected by those cells are not available. The option D is the answer. To solve the degeneracy in the transportation problem, we have to, it's option C, allocate the smallest element aplicin in such a cell which will not form a closed loop with other loaded cells. Question number 3. A problem where the produce of a factory is stored in a warehouse and then they are transported to various demand points as and when the demand arises is known as transshipment problem. Next, implied cost in transportation problem sets the highest limit of the empty cell beyond which it is advisable to include in the program. B. In transportation model, the opportunity cost is given by actual cost of cell minus implied cost. Ui and Vj are rows and columns numbers respectively, then the implied cost is given by Ui plus Vj. The problem is basically a minimization problem. Option B. The assignment problem is solved by Hungarian method. Option D. In Hungarian method of solving assignment problems, the row opportunity cost matrix is obtained by, its option C, subtracting the smallest element from all the other elements of the row. Now, in horizontal and vertical lines drawn to cover all zeros of total opportunity matrix must be, its option D, number of rows or columns. The key column indicates incoming variable. Option A. Now, the penalty for not taking correct decision is known as, its option D, opportunity cost. The solution of the linear programming problem in graphical solution lies in option A, first quadrant. When we solve maximization problem by simplex method, the element of net evaluation row of optional solution must be, it's either zeros or negative numbers. Now 15th question, dual of dual is primal. If dual has a solution, then the primal will be not have a solution. It's option A. The cost coefficient of slack variable is, its option A, 0. The cost coefficient of artificial surplus is Cm. Transportation problem is basically a minimization model. The column which is introduced in the matrix to balance the rim requirements is known as, its option D, dummy column. Operation research is the outcome of, its option C, combined efforts of talents of all fields. Now next, OR came into existence during, its B, India and Pakistan war. Now, the name of the subject operation research is due to the fact that mathematical operations are used in solving the problems. The name operation research is first coined in the year 1940. The person who coined the name operation research is McCloskey and Trefren. The objective of operation research is, its option C, optimal utilization of existing resources. Operation research is the art of giving bad answers to problems where otherwise worse answers are given. It's option C. Now 28th, operation research is interdisciplinary team approach. Now the first step in solving operation research problem is formulation of the problem. The model which gives physical or visual representation of the problem is ionic model. The Q discipline in slack of plates is LIFO. Last in, first out. Office filling system follows LIFO. Arrow discipline is generally found in lottery draw. When a doctor attends to an emergency case leaving his regular service is called non-preemptive queue discipline. Service system where customer is stationary and server is moving is found with, it's option C, person attending the breakdowns of heavy machines. Arrival, then service, then service, then service, then out. So it's a single chain multi-phase system. When the operating characteristics of the queue system is dependent on time, it is said to be transient state. The distribution of arrivals in a queuing system can be considered as pure birth process. Models measure the effect of effect of uncertainty on the behavior of the queuing system. For a simple queue, m/m/1 P equals gamma by U is known as traffic intensity. If there are n jobs and m machines, there will be sequence of doing the jobs. The answer is n exclamation mark then m. In general, sequencing problem will be solving by using Johnson and Bellman method. In solving two machines and n jobs, the following assumption is wrong. It's option D. The time of processing depends on the order of machining. The following is the assumption made in processing of n jobs on two machines. It's option B. The processing time of a job is unknown and it is to be worked out after finding the sequence. The following is one of the assumptions made while sequencing n jobs on two machines. The option A is the answer. Each job once started on a machine is to be performed upon the completion of that machine. This is not allowed in sequencing of n jobs on two machines. It's option A, passing. Write the sequence of performing the jobs for the problem given below. So the option is option A. They can be processed in any order. Johnson-Bellman Rule states that, it's option B, if smallest processing time occurs under first machine, do that job first. Two jobs, J1 and J2, have same minimum process time under first machine, but processing time of J1 is less than that of J2 under second machine, then J1 occupies, it's option B, second available place from the left. If job A and job B have same processing times under machine 1 and machine 2, then prefer either A or B. One of the differences between the resource allocation model and transportation model is, it's option C. In both models, they must be either zeros or ones only. To convert the transportation problem into a maximization model, we have to, it's option A, write the inverse of the matrix. A transportation problem where the demand or requirement is equals to the available resources is known as, it's option C, resource allocation transportation problem. The total number of allocations in a basic feasible solution of a transportation problem of m multiply n size is equals to, it's option A, m multiply n. When the total allocation in a transportation model of m into n size is equals to m plus n minus 1, the solution is known as, so option D, none of the above. The opportunity cost of a row in a transportation problem is obtained by, so option C, deducting the smallest element in the row from the next highest element of the row. In the northwest corner method, the allocations are made. It's option A, starting from the left hand side top corner. WAM stands for its Vogel's approximation method. MODI stands for modified distribution method. The optimal solution, more than one empty cell have their opportunity cost as zeros. It indicates, it's option B, the problem has alternate solution. The given sequencing problem will have multiple optimal solutions when the two jobs have same processing times under, it's option C, under second machine. If a job is having minimum processing time under both the machines, then the job is placed in, it's option A, any one first or last position. In maximization case of sequencing problem of two machines and n jobs, the job is placed at the available left position if it has dash process time under machine dash. So the option is B, highest and first. Fundamental assumption of Johnson's method sequencing is, so option passing rule. If a job has zero process time for any machine, the job must be, it's option C, process extreme position. A sequencing problem is feasible in case of, it's option C, 3 machine and n jobs. In a 2 jobs and n machine problem, A lie at 45 degree represents, so option D, both jobs are under processing. In a 2 jobs and n machine sequencing problem, the horizontal line on a graph indicates, so option A, processing time of job 1. In a 2 job and machine sequencing problem, the vertical line on the graph indicates, it's option B, processing time of job 2. 2 job and n machine sequencing problem, we find that, it's option C, sum of processing time and idle time of both the jobs is same. As per the Q discipline, the following is not a negative behavior of a customer. It's option C, boarding. The expediting or follow-up function in production control is an example of, it's preemptive, option D. In MMS and N/FIFO, the following does not apply. It's option D, single server. Now, the dead body is coming to a burial ground is an example of, it's option A, pure birth process. The system of loading and unloading of goods usually follows, it's option A, LIFO. A steady state exists in a queue if, it's option C. If the operating characteristics of a queue are dependent on time, then it is said to be, it's option A, transient state. A person who leaves the queue by losing his patience to wait is said to be, it's option A, ringing. The characteristics of a queuing model is independent of, it's option D, queue discipline. The unit of traffic intensity is, it's option C, airline. One of the properties of OR model is, it's option B, model is structured to suit OR techniques. Now, the problem which is used to disperse the available limited resources to activities is known as, it's option C, allocation model. A wide class of allocation models can be solved by a mathematical technique known as, it's option D, linear programming model. One of the properties of linear programming model is the relationship between Problem variables and constraints must be linear. It's option D. The constraints of maximization problem are of, it's option A, greater than or equal type. The slack variable indicate, it's option D, idle resources. In graphical solution of solving linear programming problem to convert inequalities into equations, we, it's option D, simply assume them to be equations. Convert greater than type of inequality into equations, we have two, it's option D, add slack variables. To convert less than type of inequality into equations, we have two, it's option C, subtract surplus variable. Graphical solution of maximization problem, the line which we move from origin to the extreme point of the polygon is, it's B, isoprofit line. The assignment matrix is always R. It's option B, square matrix. To balance the assignment matrix, we have two. It's option C. Open either a dummy row or column depending on the situation. In cyclic traveling salesman problem, the elements of diagonal from left top to right bottom are, it's option C, all are infinity. Convert the assignments problem into a maximum problem. It's option B. All elements of the matrix are deducted from the highest element in the matrix. The similarity between assignment problem and transportation problem is, it's option D. Both have objective function and non-negativity constraints. The total opportunity cost matrix is obtained by doing, it's option B, by doing column operation on row opportunity cost matrix. Following character the assignment matrix is a square matrix. It's option A. The allocation in assignment problem are 1 or 1 to 1. When we try to solve assignment problem by transportation algorithm, the following difficulty arises. It's option C. The problem degenerate and we have to use Epsilon to solve degeneracy. The objective of sequencing problem is, it's option C, to find the sequence in which jobs on hand are to be processed to minimize the total time required for processing the jobs. The time required for printing of the 4 books ABCD is 5, 8, 10 and 7 hours, while its data entry requires 7, 4, 3 and 6 hours respectively. The sequence time that minimizes the elapsed time is, its option D, CBDA. This was the last question. And if you want the PDF of this question paper, then you can comment below. And I have read the questions so that they will settle in your mind and it will be easy for you to remember these questions. But still, if you want that PDF should be there, then you can comment below. And don't forget to hit the like and do subscribe to the channel to keep supporting me. So this is it. Goodbye and take care.